Hi students, this is the second day of proving trig identities. We're going to learn to use two different strategies in our proofs. Okay, bear with me, let me get to the slide here. So we've learned lots of different ones, and this identity we actually did write down, but we're going to talk about it a little bit more and write down the rest of these. So for this, if you want to think of your unit circle, and let's see, our center, and let's just have our X and Y axes, and let's just call this angle theta. Okay, so this is our R, or our radius. This vertical piece here would be our Y, which is the sine of theta. And this would be X, which is the cosine of theta. And the center here is at 0, 0. So when we think about this in looking at this unit circle, we know the Pythagorean identities stem from the Pythagorean theorem, where we can say that x squared, actually, when you did this in geometry, you did a squared plus b squared is equal to c squared, and c was the hypotenuse. So let's think about the triangle we have right here. We have an x, a y, and an r. So let's go ahead and translate into that. X squared plus y squared is equal to r squared. Now we know the radius is 1, so 1 squared is just 1, and x is also represented by cosine. So cosine squared theta plus sine squared theta is equal to 1, and that's going to be the first Pythagorean identity. So cosine squared theta plus sine squared theta is equal to 1. Now, the other two identities are going to stem from this first one. So we're going to say, okay, let's say if we take this original Pythagorean identity, and why don't we go ahead and do some division and see what happens? So if I divide both sides by, let's say, sine squared theta. If we do this and we divide both sides by sine squared theta, don't forget we have to divide each of these like this. We're going to split that fraction. So we would get, in this case, we would have cotangent squared theta, and that's because of the quotient identities, plus 1, okay, and that's equal to cosecant squared theta, and that's the reciprocal identities. So that's what's going to go in here. Cotangent squared theta plus 1 equals cosecant squared theta. Now we're going to do the same thing. We're going to divide this time both sides by cosine squared theta. So we'll take our original Pythagorean identity. We'll divide both sides by cosine squared theta. Don't forget we have to split the fraction. So when we divide here, we get 1 plus tangent squared theta. Again, the sine squared theta over cosine squared theta, because of the quotient identity, is tangent squared theta. And then 1 divided by cosine squared theta is secant squared theta. So that's our third one. Now you have this in your organizer. You likely already have the 3 boxes filled out, but the reasoning below is why these work. Okay, so we're going to use the Pythagorean identity in some of these proofs. So this first one has secant squared theta minus tan theta cotangent theta has to be equal to tangent squared theta. So let's see what we can do here. We know that in the end we want this tangent squared. And I do see that I have a secant squared theta. So looking back here, what does secant squared theta equal? We're over here. It equals 1 plus tangent squared theta. So I'm going to do a little substitution here. We're going to put in tangent squared theta plus 1, or 1 plus tangent squared theta, doesn't matter, minus tan theta cotangent theta. And our reason for this is going to be Pythagorean identities. Pythagorean identities. And that's what our strategy is here. Pythagorean identities. Okay, so let's see what we can do next here. So we do have the tangent squared. That's good. Maybe what we can do is write cotangent in terms of tangent next. So tangent squared theta plus 1 minus tangent theta times 1 over tangent theta. And that would be because of the reciprocal identities. So let's go ahead and write that in, reciprocal identities. Okay, and now our next step would be to cancel. Okay, we can go ahead and reduce or make ones. So we'd have tangent squared theta plus 1 minus 1, and now this is looking even better. So we can say here, reduce, you can say make ones, that's fine too. And now we can go ahead and combine like terms for the next step. And we're going to get tangent squared theta equals tangent squared theta. And so our last step here will be just to combine like terms. And then there's our check mark there. We made it. So again, you're going to have practice that's going to be using all the different tools. But this is practicing at least one of these specific tools using Pythagorean identities. All right, so the next one on page 9 here with this strategy is a you try. So if you'd like to pause and give this a try to at least start, you're certainly welcome to do that. If you want to hang out with me and do it with me, that's fine too. Okay, so I'm seeing that this sine squared theta, so again, eyes on the prize, we want this 1 plus cosine theta. So sine squared theta, let's see what sine squared theta equals. Here's sine squared theta. So what I'd have to do is subtract cosine squared theta from both sides to get sine squared alone. So it would be equal to 1 minus cosine squared theta. 1 minus cosine squared theta. Because remember, cosine squared theta plus sine squared theta equals 1. If I want sine squared theta alone, I would subtract that cosine from both sides, that cosine squared theta. And now we can make a substitution over 1 minus cosine theta. Okay, reason for this is Pythagorean identities. And now, I know I just want 1 plus cosine theta. And what I'm looking at is, we have two terms up top, and we have this squared here. So I'm thinking, can I factor this? And in fact, it does factor into 1 minus cosine theta times 1 plus cosine theta. And you can certainly use the area model. That's absolutely fine. Okay, so this is just that we are factoring. And now, look what happens. We have a common factor that cancels. So we can go ahead and reduce or make ones, and then we're left with 1 plus cosine theta. And that's what we wanted. So we can say here, make ones, or reduce is fine, and then we are done. Okay, so that is the strategy Pythagorean identities. Okay, so now we have one more strategy that we are going to cover, which is multiply by 1. Multiply by 1. And it's going to be a special one that is going to do something nice when we actually multiply it. So one of the things when we look at this first example, let's jump right in here, is we have this 1 minus sine theta in the denominator. So let's see what happens when we multiply 1 plus sine theta times 1 minus sine theta. So you can do an area model, or if you'd prefer to just distribute here and here, doesn't matter. So it's the same exact thing. So we'd have 1 minus sine theta plus sine theta minus sine squared theta. And look what happens here. Those two terms cancel out, and you're left with 1 minus sine squared theta. So something that you will see is that when we multiply by the conjugate, which is the same two terms with the opposite sign. So that is the conjugate. Okay, I think I spelled that so crazy. Hold on a second. Okay, so the conjugate has the same terms. Wow, and my writing is just ready for summer. Same terms with opposite sign. Okay, so let's give this a try. So we're going to multiply by 1 plus sine theta over 1 plus sine theta to the original. So we're going to multiply, and that's really just multiplying by 1 because it's the same thing, you know, over itself. So really, this purple fraction is 1. So that's totally legal to do. So we're going to say here, what do we do as our step? Is we multiply by 1. And that's our justification. Okay, so now what happens when we do that multiplication? So this, when we do the multiplication, we're going to see that we get this 1 plus sine theta times cosine theta, and we'll end up distributing that. And in the denominator, you're going to get 1 minus sine squared theta. Okay. So, and this is still going to be the multiply by 1. So this is kind of, I did it in like 2 steps, but really that's what we're having. You could put this little purple fraction up here, but I had this example and that was kind of in my way. So you might want to write it there, and then this is your actual first step. Okay, so from here, 1 minus sine squared theta, let's remember, cosine squared theta plus sine squared theta is equal to 1. So if we subtract sine theta from both sides, cosine squared theta equals 1 minus sine squared theta. That's exactly what we have. So let's go ahead and see if we can make a substitution here. Again, you might do a legal step and it might be a mess and it might not help, and then you need to go back to the drawing board. That's okay. But let's go ahead and put in cosine squared theta. And so from here, we would be able to say Pythagorean identity. Okay, from here we can do some reducing. Let's see here. We can cancel out 1 and 1 there. So we would have 1 plus sine theta over cosine theta. And so we can just say, oh, and I forgot the minus tangent. Oopsies. So we can say reduce or make ones. And let me get that tangent back where it was, minus tan theta. Okay, I'm going to erase this conjugate here so I can have a little space. Okay. So moving along over here, let's write tangent in terms of sine and cosine. So I'm going to say 1 plus sine theta over cosine theta minus that sine theta over cosine theta. And the reason for that is going to be the quotient identity. Now I can actually combine those two fractions. So let's go ahead and do that. 1 plus sine theta minus sine theta all over cosine theta. So we can say, we really can just say we subtracted, right? And we were able to combine the fractions. So subtract. Now let's combine those like terms. I see them canceling out right there. So we can go ahead and combine those and we'll get 1 over cosine theta. The reason is combine like terms. And finally, we want to get this to be secant, and we know by the reciprocal identities, this is secant theta. And that's exactly what we wanted to prove. So we can say here reciprocal identities. So it's quite a few steps. Some of these you're going to find a more efficient way than I do, and sometimes vice versa. I might find a quicker way than you, but it's really not about doing it as fast as possible. It's about doing it so that you can actually verify and prove the steps you are doing are legit, that we're able to do these mathematically. All right, here's a you try one. So for this one, if you'd like to pause and give this a try, go for it. Let's go ahead and see what we can do with this next one. All right. So I'm seeing with this next one, let's try to do the multiply by 1 with that right fraction. So maybe I'll try to squeeze this in here. 1 minus cosine theta over 1 minus cosine theta. So that's going to be cotangent theta plus sine theta times 1 minus cosine theta all over 1 minus cosine squared theta. Again, when you multiply that out, the two terms will cancel, and you could certainly do that on an area model. Okay, so this is multiply by 1. All right, now from here, I'm seeing I can do some factoring in the denominator. So let's go ahead and do that. So cotangent theta plus sine theta times 1 minus cosine theta over 1 minus cosine theta times 1 plus cosine theta. Oh, I don't want to do that at all, do I? No, that's just undoing what I did. That doesn't make any sense. What I want to do is I want to think about my Pythagorean identities. So cosine squared theta plus sine squared theta equals 1. Now, in the denominator, I now have 1 minus cosine squared theta. And what that would equal would be sine squared theta. Okay, so our reason here is Pythagorean identity. Now we can do the canceling. So now we would have cotangent theta, oops, not equals, plus 1 minus cosine theta over sine theta. And the reason for this is going to be just make ones or reduce. Remember, we're trying to get cosecant of theta, which is just a single term. So let's go ahead and write this cosine theta over sine theta plus 1 minus cosine theta over sine theta. And so this reason is going to be because of the quotient identities. Okay, almost there. We see that we have common denominators. So let's just go ahead and add. So we would say cosine theta plus 1 minus cosine theta all over sine theta. And we can just say for this one, our reason is we just add. Now we can do some canceling. And that's just when we combine those like terms. So 1 over sine theta is because of combining like terms. And now we can say cosecant theta equals cosecant theta, and that is due to the reciprocal identities. And now we're done. Okay, so I really feel that you trying these and practicing and kind of, taking a path and seeing it out is going to be the best way for you to learn these different methods. So last time you had page 12, problem 1 and 2, and then page 13, there were several problems here. This time, I want you to do problems 3 and 4. If you have not done 1 and 2, I'm going to say do all 4 of these first, okay? And then you can kind of start picking some of these and go back to the first chunk too if you need to, if you haven't finished those. Check your process with my key. We might have a different way to get there. So please ask if you're not sure. If you think, I think what I did is correct, but it's not matching, please, please ask. Okay, have a wonderful rest of your lesson.